Okay, hi guys. So today we'll be solving little problem, closest prime number in range. So let's see the description. So we're given two integers left and right, positive integers, right? So we need to find the two integers num1 and num2 such that num1 is smaller than num2, and both these guys has to be in range of left and right. And we need to also make sure that num1 and num2 are prime numbers. If you don't know what prime number is, here's the definition. A prime number is a natural number greater than 1 with only two factors, 1 and itself, right? We also need to ensure that num2 minus num1 is minimum amongst all other pairs. Since left and right there can exist multiple number of prime numbers in between them, there can also be multiple pairs, right? So we need to return the pair that has the subtraction between num2 and num1 is the minimum. Need to return answer in the form num1, num2, basically a list, and if no such number exists, return -1, -1. So if there's only like smaller or equal to smaller than 2 prime number in between left and right, so we just return -1, -1, right? Okay, so when dealing with problems related to prime numbers, right? They're basically like an old ancient method to generate all prime numbers up until a number, right number, and that method is called Sieve of erasthothenes. So I don't know if you can see the screen, but here you can see that here we have a list of number from 2. So now, for example, if our upper bound is 100, right? I need to generate all prime number up until 100. What I'm going to do is that I'm going to iterate through each of these numbers, right? So 2, I come to 2, so we already know that 2 is the first prime number. It can only be divided by 1 and itself, so it's a prime number. So all of the multiples of 2 has to be non-prime, right? So 4 has to be non-prime, 6 has to be non-prime, 8 has to be non-prime, and vice versa up until 100, right? So we will mark all of these guys as non-prime. So here you take a look. Here I come to 2. I marked all of these 2 here, right? 4, 6, 8, 10, 12, 14 up until 100 as non-prime, since they are going to be divided by 2, 4, and 1. These guys 2, 6, and 1, right? Okay, so it's not a prime number, it's a non-prime. I'm going to mark it. Now I come to 3. 3 is not being marked, so I know that 3 is a prime number, so I'm going to use the same method. I'm going to mark all multiple 3, 6, 9, 12, 15 up until 99, 100, right? And I keep on doing that, and all of the guy that is unmarked, it is prime number. So we have successfully generated a list of prime number from 2 up until a number that we want, right? So that number here is right. Okay. After that, then it's very simple, right? We can just compare two adjacent prime numbers and then see if it's the minimum, then we return it. Because there can be multiple pairs, right? But the pairs that satisfy this condition has to be two adjacent pairs. It's pretty obvious, right? Okay, so what I'm going to do is that I'm going to create a list called is prime. This is going to be evaluated true first, right? This one, which you can see that since the list is indexed from 0, we need to multiply it by plus 1 so that we can come to the record. Okay, so here's if the record is 3, I want each of the index to be equivalent to that specific numbers, so if I'm going to, let's say, call true multiplied by rect, it's only going to generate me 3 numbers, but the rect mode index will be 2, right? There are no 3 index, so hence why I need to do rect plus 1. Now for n in range, so the first 2 number is actually non-prime, right? False. I set it to false. For n in range, 2 int rect here. Okay, so here's actually a trick to actually optimize this method. We don't need to actually do a for loop up until the rightmost element, right? Why? Because okay, let's say that n is prime number and it can be written as a multiple by b, right? So these two guys can be prime or non-prime number or composite number, right? And it basically has a prime factor, right? So the prime factor here can be anything from the range of left to right, but now what I'm going to say that there will be at least one prime factor that is smaller or equal to square of n. Else, if both of these guys is actually prime factors actually larger than n, square of n, right? So when we multiple these two guys, we will get something that is larger than square n square n, and that is n, right? So since a and b is evaluated to n, which equal to n, right, it cannot be larger than n, right? So at least one of these two guys has to have a prime number that is less than square of n. So and if there's one guy that is actually has prime number that is larger than square of n, right, then that guy's will have all of these multiple marked by the one that is smaller than it, right? So we don't need to evaluate to loop through anything that is past the square of n, right? So the n here is actually right. So now if is prime n for I in range for multiple, let's call for multiple in range from 2, no, not 2, right? Is actually n up until right plus 1, and the step will be n, right? we will mark this guy as false. So let's print is prime. Return something like this. Let's say that the left will be 1, right could be 3. No, let's generate up until 11, right? Multiple. Okay, so first two guy is not a prime number. 0, 1 is not prime number. 2 is prime number. 3, 4 is not a prime number. 5, 6 is not a prime number. 7, this not 8 is not a prime number. 9 is not a prime number. 10 is not a prime number. 11. So it's working correctly, right? So now we'll create a variable called result, and then the previous prime number will be set to none, right? And then let's say that for n in range left, right plus 1, if is prime n, if ref prime is not none, and rest 0 is equal to -1, or rest 0, 1 minus rest 0 is actually larger than n minus ref prime. Okay, so what does this mean, right? So the previous, we need to have a previous prime so that we can like form a pairs of prime numbers, right? And then if we have the previous prime number, and then the if we take this, we already have a candidate that we have evaluated, right? So we need to compare the subtraction of rest 1 minus ref 0 to the current number minus the previous prime number. So if this guy is evaluated to something that is larger than our current candidate, then we will update it, right? Or since the result is by default is set to -1 -1, then if we get rest 1 minus rest 0, it will also already be 0, right? So we need to do this. So basically, if result is not set, or rest 1 minus rest 0 is actually larger than our current candidate, then we update it, right? So rest run rest 0 0 it will be equal to ref prime and then the current number, right? So after that, then we will update our ref prime to n, right? And that's it. I do think that's it. And then we just return rest, right? Yeah. Yeah, okay. Okay, so that's it for today. So if you care about the complexity, it's actually quite complicated. It's O n log n, right? You can see here it's actually O log n, right? And log n. Actually, it's not that efficient as I've thought. Let's see what people are rating. Miller Rabin. I know. Okay, so that's it for today. I hope you guys understand the solution, and see you guys in next video.